One.
Just started.
Okay. So IR resist is taking into consideration new lesions primarily. And it's based on resist. Okay. Now WHO uses response criteria. Has nothing to do with resist. So IR resist and IRRC are two different things. Kato used IRRC, which is two-dimension based. In IRRC, progression is defined as 25% increase in tumor burden from the lowest level recorded. It's not 50%. So they clearly did not use the progression definition by IRRC. Okay.
Okay.
So when I'm saying did they use progression definition, the answer is no. Okay, they use their own definition of 50% to define hyperprogression, and they did not include progression definition.
Understood.
So I want you to really study the field. This is your paper. Okay, do not be confused about what is response criteria, what is resist, what is IRRC, what is IR resist. The four of them are all very different, adapted very differently. Okay, I'm just trying to teach you because it might be very confusing to you.
Thank you.
And these are all in internet. It's not like, oh, I don't know where to look up. If you Google it, you can learn yourself. Okay.
Understood. Yeah.
So my final comment, it's taking too long. Okay. Comments that I give you should be reflected in 24 hours. Okay. I think my concern is that Eugene, you'll be busy doing clinical work in Cook County very soon. I think this has to be really fast turnaround and submit. We're still seeing a lot of scientific inaccuracies, and you need to study really hard to get rid of these inaccuracies. Okay, we're not just doing formatting here. We're trying to make a publishable quality paper here. So Arnie and Eugene, I think you guys need to work harder to get this published in next 1 week. Okay, let's get it out in 1 week. We've been working on this too long. I mean, usually it's not this pace. So
I'm sorry.
I want you to, I was very disappointed when you said, oh, this is just the formatting we want to show you. You know, the formatting will happen in 24 hours, okay? You can ask me the format. And this is time to really sit down and look at what you're going to submit. If this pace goes on, I honestly don't see this is going to be published next week, okay? You have Jian and people, you know, around you who's trying to help you get this around, get this out in real time. Haesung's here, Liam is here. So you can work with them to ask me questions, okay? And if they're a burning question, you can always send me, oh, do you like the format? I'll answer you that question right away. Haesung does that all the time. Jian does that all the time, okay? They don't even meet me in person, but they send me text for the burning questions. If you send me burning questions once a week, I don't expect the project to be moving. Okay. If you have specific question, feel free to ask me anytime. My expectation was to see publishable, scientifically and grammatically correct, you know, manuscript out. 1 week is enough. If you guys are working in clinic, like Yoonhee, you know, having 1 week time, non-clinical is so precious. You know, you can write one paper in 1 week. I'm not kidding. Okay, but just to fix view, spend 1 week, I don't get it. Okay. And a lot of people do their clinic time and go home and write up paper. And with that, you can write a paper in 1 week. That's the life of residency, residents or fellows. You use your time to produce, publish. So I'm a little disappointed at the pace. I know, Eugene, you have 5 other projects. I don't know where they are. But I just, want to see, because if things get busy, then it gets lost and you'll be taken off the project, which I don't want. Okay.
Understood.
And the first year of residency is pretty tough. So I want a little bit, I guess I want more completeness, and I'm not happy with the pace I'm seeing here.
Yeah.
Anything else before we wrap up?
I just say I'm sorry, Dr. Che, and we will try to speed up this week. I promise, I promise. So sorry.
All right, let's see what we have next week. Okay, we'll move to, I don't think Jui can come today, but let's go to Maria.
Hello, good morning to everyone. Right now we are working on the hyperpolarization, the radio mix project. Right now we are uploading all the CDs, working on doing the tables also. And we are working with Maddie and Peter uploading the CDs. We are almost finishing. In total we have 185 patients. We are 135 today, so we expect to finish this week. They are working on finishing some tables, doing the percentage and everything, and that will be all from my standpoint. I think that Dion have a more thorough view of the project, but now we are working on the stuff, the tables. I'm now loading the CD so we can start segmentation right away. I think that probably the end of this week or the next week.
Great. It's taking time, but yes, thank you. Any questions?
No, so far. I think that Dion is really good at answering the question right away when I have anything to that I'm not understanding well. So everything is good.
Great, thank you. Okay, Haesong.
So we cannot hear you.
I'm so sorry. So I wanted to first talk about Dr. Nam's papillary thyroid cancer project regarding the phenotypes of TIC or TIL score. Yeah. So these are the comments that the reviewers have given us. These are the questions, and these are the answers that Dr. Nam and I have prepared. Would you like to please go over the comments? So the first reviewer mostly commented on the clarity, on the novelty, and the clinical impact. And he says he tried to describe the novelty of the study without having to. Well, he said heterogeneity is inevitable due to analysis of single tissue biopsy, and he wasn't sure about what the reviewer meant by cell-to-cell interaction.
If the special information could be harnessed to assess heterogeneity within tumors and cell interaction. I mean, it's the same thing. Right now we're doing spatial genomics where different probes are used to stain different parts of the slide. I mean, we don't have that. So this is based, I think is single. So there is no special distribution. Well, I guess the RNA interaction. Wait. So heterogeneity within tumors and cell interaction. So the current so we did not stain cells anything other than H&E. So we're using H&E to define what's stroma, what's tumor, and what's lymphocyte.
Mhm.
So that interaction between tumor, lymphocyte, and stroma is assessed using 3 different categories: hot, immune, excluded, and desert. But we agree that if we had more slides, that we could do special genomics or do special probe staining, then we could see more in depth in terms of describing what immune cells are next to what other immune cells or next to tumor and all that information. And we agree that is the next step, but with what we have, this is what we could show. But we do agree that dissecting the interaction between different immune players in tumor cells and stromal cells is the next step. But our work is, a pioneering work, but because I don't think there has been any H&E based artificial intelligence platform that was used to describe the immune landscape this way. And this will be a stepping stone for the next work, which is the special genomics looking into cell-to-cell interaction. That's how I would respond.
Yeah, wonderful. Thank you. Then this one talks about the clinical impact and asks whether there's a correlation with metastasis or recurrence, any pathways or gene signatures associated with outcome. And it talks about how there's a notable difference in terms of lymph node metastasis and excluded IP. But in terms of survival, there was no difference between the IPs. And then we said like further studies, perhaps with advanced cancer patients.
So are these in table or figure?
The outcomes are, and then the metastasis correlation, no.
So maybe we should include that. It not just say in the response letter, but you can add that in the supplemental figure or table, whichever format, and just briefly mention that in the results. And say that in the newly revised manuscript, page number, so we added the following paragraph or sentences, and you put that in the response letter as well.
Okay.
Okay, good.
Good idea. Yeah. Just rephrasing some sentences, and then This one was a major one. It says maybe this reviewer suggested deleting the paragraph that talks about the correlation with survival outcomes and just put it in the supplementary section. Then instead add, a section where you correlate your different IP score to the risk of recurrence as PPC. And so because the information was very limited on the TCGA, we used the 2009 ATA guideline for the risk of recurrence instead of the 2015. And if you look there, the risk of recurrence is stratified by low, intermediate, and high. And then we divided by the IS scores as such. And then found that the chi-square, didn't show any differences. No, I flipped it by the desert excluded thing. Chi-square is significant, but post-hoc pairwise comparison only significant between desert and excluded.
So, okay. So this was done based on the guideline. This is the total TCGA patient number,
Yes.
432.
Yep. Yes.
Mm.
With the risk of recurrence data.
Mm. So explain this chi-square again.
Just stratify, just compare the IS scores versus the risk of recurrence. Dr. Nam ran the analysis. So, yeah.
Okay, go down. So low, intermediate, high. What is?
Well, according to the ATA guidelines, the risk of recurrence is, divided into these three categories. And no, it's by like how many lymph node involvements there is. Yeah, there's like specific categories that defines what's low and what's intermediate, what's high.
Was there a trend for anything?
It didn't seem like he said only significant between desert and excluded. But overall, not so much.
What does that mean? Desert included has more lows?
Excluded definitely has a lot of intermediates. Desert, yeah, tend to have low risk of recurrence.
So let's go back to the reviewer request. Say you can delete. This is not the aim of your study. So it's okay to move them to supplement. It's okay.
Do you agree? So I think we got confused because PFS, I feel like that kind of sounds similar to risk of recurrence. Or recurrence maybe means, recurrent disease after complete cure following surgery. And progression assumes that there is still a disease before that the patients had not been cured by the surgery.
So do you have the stage, like the table 1? Because the whole stage, the TCGA data is local disease. So here stage 4 is 10%.
Yeah.
And let's look at M1 is 3%. Hmm. I don't know if the TCGA data describes it as PFS. Most of it is recurrence-free survival because they're non-metastatic mostly. That's why it becomes tricky. For lung cancer, Signatera paper we wrote, you know, other than Albert Curie, everyone was non-stage 4. So
Mm,
here it's like 10%. So I think you have to use PFS then because of that 10%. It includes the recurrence-free survival for non-stage 4s. So that's okay. And per reviewer's request, it's okay to move them to supplemental. Let's go back to the comment.
But so are you saying PFS includes the stage 4 cancers? Or
Mhm.
like okay, but the risk of recurrence doesn't really talk like we can't infer much information about metastatic disease with risk of recurrence.
But for the sake of analysis, it's okay to just
Okay,
still use all the data. It's okay.
okay.
So the reviewer is asking, add a section in which you correlate your different IP score to the risk of, you must add a new figure. So it's a must. So you can make that table. Both tables can be added as a supplemental. And all these should be added in the methods and results. The reviewer is asking that we do it. So do it. In the same thing in the manuscript web page, what was incorporated, show that in the reply letter as well. Also, just make a new figure. So where's the figure?
We haven't made one yet, but we also wanted your input in like what kind of figure that we're supposed to make. I think the tables kind of tell the story, but I'm not sure what figure they want.
Yeah, good question. So, I think you can do it. So this table can be in supplemental. So the people who want to look at actual numbers, you can make a creative figure. Now go down. You can make a pie chart. Let's say, oh yeah, you can do it. You can make a figure A as the first table, and it will be a graph. X-axis is the IS score. Is what IS stands for what?
Means or
Immune is it?
oh me. I thought of it as IP all along. But, I'll clarify that with Dr. Moore.
Is it in the manuscript? Is it immune score?
I don't think we used term.
Oh,
Oh
inflamed.
yeah, the inflamed score. Yeah.
Okay, inflamed score. So I'm just gonna give you example. The x-axis could be the inflamed score in 1, 2, 3, 4, 5 different categories. And you can put, intermediate, low, total in different colors in 5 different bars going up.
Mhm.
Table 2 could be a pie chart where there is low, intermediate, high would be 3 separate circle, and within that you can put desert inflamed excluded inflamed as 3 pizza slices in different colors. So that way you can have 2 different dissection of what's happening.
Thank you for the idea. Okay, yeah, I think that's the main thing.
Okay.
Okay, so that's it for Dr. Nam's project, and then
Oh,
for mine, yeah.
So I think that are they calling it major or minor revision?
No, it's minor.
Okay. Yeah.
So overall, it was very positive. Yeah.
Good. I think it has good chance of getting in.
Yeah. For mine, I finally was able to get a very clean data. This one I was just about to do, just fill in the things. Anyways, yeah, so I actually made a lot of mistakes while extracting the data, so I had to redo things all over again, and so it's not completely ready. But just wanted to show you, it's I'm just about to start the analysis. I wanted to just tell you a few things. So you know how I asked you a few questions about the retransplant outcome, what we should do, whether we should consider the second, graft failure outcome and stuff like that. But since we're only thinking about time it takes to the first diagnosis of PTM, I thought we should probably just focus on first graft failure due to graft rejection, because once we consider the second one, I just feel like there's also not that many patients. There were only 88 patients who were assumed to have graft failure after the second transplant, and 87 patients of them. So 87 out of 88 patients were kidney transplant. So it's not like there were many variations among the organ types. So I just thought it wasn't worth considering them, so I took them out. So basically, our final outcomes are, just alive, death, and then retransplant. So those are our 3 main outcomes. That's what I decided to do. And if you don't like that, please let me know. And then for HLA mismatch group. Oh, actually, I'll just show you this. So as we talked about, the ABO match rate is very high. It's like 99%. We only have like 0.8% of patients who have ABO mismatch. But for HLA, the mismatch rate is 83%. And so for ABO mismatch, the match should be the reference group, whereas for HLA mismatch, the mismatch group should be the reference group. Is that correct? When I'm doing the analysis. So this is match versus mismatch.
Well, I guess in transplant world, what is HLA mismatch? How is it defined?
I read a couple papers and it seemed like more than two mismatch across the loci.
Okay.
Right, it's
So
considered
then
mismatch.
you say that in your method. That's probably what it is. I
Yeah.
mean, it's the commonly used definition, then yes. So in solid organ, ABO is important than HLA. In liquid transplant world, HLA is more important.
Would you still like me to include HLA?
Uh-huh.
Okay. But the reference group should be mismatch in this case, is that correct? Because I think last time you said the greater number,
Yeah.
with the greater number is the reference. Okay. That's it for that project. Oh, and then for the TAP one, we finally got a reply, and they said they can try to deliver the data by the end of June, but they'll try to do it more quickly. This is for the heterogeneity project, and as well as I think the Discover Mucinous Avenue project.
Okay, I think we're just at their mercy, right? I mean, we
Mhm.
offered many different things and they're
Yeah.
right. I even met what's his name? The guy. Um Kevin Chow
Yeah.
at San Francisco.
Oh,
Like young, I want to help, but legal team is making it, very slow. So he's
yeah.
doing what he can. So can't blame anyone here. But
Yeah.
see
It
how
just
difficult,
sounds like it's gonna take some more time.
yeah, see how difficult it is to launch any project.
Yeah.
Uh, so I want to tell you a funny story. So I actually wrote a poem about this too.
What's
Too
the title?
late. But I forgot. It's about project or something. So it has a profound spiritual spiritual lesson here. Um, so now Handsong understands to lay foundation of a project is very difficult. First, you have to propose a lot of back and forth. Are we gonna get the grant? Are we gonna get the support? When are you gonna give me the data? In what format? And when you get it, it's not clean. I have to clean it.
Oh my gosh.
And then
완전 멘붕.
and so Hesong understands. I'm glad you're like me now. Laying foundation is not trivial, okay? And someone who got the clean data and they like collect, based on a clean Excel spreadsheet, clean data and just transfers things and analyze it. And they complain. So much work. I've done all the work. I'm the first author. Give me all the credit. And person who laid foundation hears that and like, who laid the foundation? You know what I mean?
Yeah. Yeah.
So,
I think after this, I've learned that I'm never gonna complain about authorship ever again.
without the funding, without the collaborator, getting them engaged and,
Yeah.
getting actually the data and for like, a lot of blood samples, someone had to collect them, get, you know, um, someone had to write the protocol. And that protocol was probably the 10th protocol they wrote. And then 9 protocol, written were rejected. And then the person who laid foundation goes into fellowship. And that's the person who comes next forgets who actually laid foundation. So
You've done
this is,
all of that in MD Anderson.
yeah, this is like the life of a researcher. And but so this is getting spiritual here, but I will say it. But when Job, in the book of Job, in the Bible, scripture said, and he complains to God, you know, and then God hears all that, and he says to Job, who laid the foundation of this world?
Yeah.
Were you there when I made all this? No. It's like radiomics project. Oh my God, I have to do the segmentation. And there's too many patients. And then someone else comes, you know who laid the foundation? So I just could relate to God when he said, you know, who laid the foundation. Kind of feels odd to say I can relate to God. But yeah, we keep trying, but yes, so the Mike, you know, it just laying foundation is so important. But yeah, thanks for following up, and okay, I'm done with my part.
Thank you. Thanks for the advice. Could I just get a quick
Yeah.
just I don't know, just a bit of comment on like how I'm supposed to get the stipend. Like what kind of, they said I need to fill this out. You and I both need to fill this out to get the stipend, but
Mm.
we haven't really started anything. I'm not really sure what to write.
Yeah.
Do you think we should do this later?
Yeah. Let's do this later. We have to give it more
Okay.
thought, and
Okay.
but it's not just since getting the data, you have to put time, kind of spend time learning, and the learning the statistical analysis, you know. So put every time you put into this project, not just dealing with touching the data. Okay.
Right, thank you.
Anything else?
No, that's it for now. I'll work on the project further.
Okay, good. Gion.
Yes.
Three papers are in under review, and two papers are in under review, and one is in revision. And it seems like it's still editor holding this paper, but we'll see the result. And regarding RadioMix, all clinical data collected, and I analyzed with the statistical analysis. And I made the tables. I need to show you the table. Table 1 and 2 is table 1 is clinical pathology characteristics of patients with non-small cell lung cancer based on the tumor response at first CT scan, what I showed last week. And I would like to ask you whether the median should be written with a range or interquartile.
I think range is fine. Range is fine.
Okay. And here, what about also TMB used with range?
Yeah, range is fine.
Then all I will do, like with the median with a range.
Yeah.
And this was the outcome based on the tumor response at first CT scan, what I showed you last week. And regarding duration of treatment, do you want to use mean or median zone?
Duration of treatment, median.
Median with a range.
Yeah.
This table is mycopathology factors based on the durable response at least 24. You look at this, the histology type of tumor. Squamous cell carcinoma show the higher frequency in durable non-responder.
Durable. Wait, there's durable responder and take out the word durable.
Or take out, okay.
No. The second column on the,
This one?
yeah, let's call it non-responder.
Oh, okay.
As
So we
opposed, yeah,
should be,
we'll still understand it's not there, there's no durable
Uh-huh.
response. Yeah.
okay.
So you're saying non-responders have more, what, more squamous or more?
Squamous cell carcinoma.
Yeah, I guess the proportion is higher. Interesting.
And there was no significance regarding PD-L1. And tumor stage, the higher stage were identified in non-responder. And just like the tumor response at first CT scan, it showed a statistical significance in type of treatment. When the patient received containing chemotherapy, then more patients got show the response.
Okay.
Outcomes. There was a significance in pneumonitis and liver metastasis. More patients showed the liver metastasis in durable response.
Liver mets had more durable responder.
Yes, but interestingly, in the response at first CT scan, it was not. There was a significance, but it showed the reverse result.
At first scan, okay. Interesting.
Actually, I don't know how to understand this concern.
I think it's all random chance.
Oh, okay.
And clinically, people use durable response more, as you've seen in. So maybe we can use, because they're all similar, durable responder table as a regular table. And at first scan, you can make that supplemental.
Supplementary, yes, okay. And this is progression-free survivor with response at first CT scan. There was a significance between two groups. And also overall survivor there was. These two should be the supplementary. And this is the progression-free survivor result based on the response at least 24 weeks, which means a durable response. There wasn't significance between two groups in progression.
Responder nerve.
But there was the significance in overall survivor. I think because even if the patients was belong to non-responder, at least 24 weeks, the treatment was maintained. So there wasn't progression until then.
So here's what I think. Non-responders,
Mhm.
are you saying that the 40 patients received treatment for 24 weeks at least?
Yes.
Hmm.
But I took the best response during the treatment.
Yes. Best response is the right way to do it.
Yeah.
But
So if there was any chance, any result with the progression during the treatment, that patient should be go to the non-responder.
yeah, they should have first scan PD or second scan PD, doesn't matter.
Yeah, yes,
At what
exactly.
point, if the only response they had is PD or non-responder, yeah, it's like anyone who does not belong to responder is non-responder. Is that what you did?
Yes, yes.
Okay. Yeah, so some people got off therapy after the first scan in this blue graph, right?
If the patient stop the treatment, that patient should be excluded from this responder or non-responder because the treatment didn't maintain at least 24 weeks.
Oh, so
Only patient who received the treatment at least 24 weeks, they are included in this.
oh, I see in this analysis.
Yeah.
I
Is that right? That I
no, I think you should put people who received less than 24 weeks still in the non-responder.
Oh,
Yeah.
okay.
Yeah. So the at least 24 only pertains to the stable disease. So durable response, for the sake of the manuscript, let's say so last time I told you that these like responder is different by paper by paper.
Yes, yes.
I mean, if you just use the response resist criteria, it doesn't have any durable response criteria. It's it's by the paper. But the resist criteria goes by the best response.
Yeah.
So so this is what I would say. If you have CRPR at any time point, even after 24 weeks, doesn't matter. Okay? If your best response is CR or PR, then you belong to durable. Or if you have stable disease, at least for the first 24 weeks. So that first 24 weeks belongs to 3 categories: CRPR, SD. But the CRPR could be, CRPR in 1 year. Doesn't matter. But at least they are SD. If they're PD, they're not, So it ends up being, CRPR, SD at least 24 weeks. I mean, and non-responder is whoever does not belong to this group.
Oh,
So there's no definition that they need to be on treatment for 24 weeks.
okay.
Yeah, that will change this graph.
Mm-hmm. Yeah, then the number of patients in durable responder is still 64, but non-responder should be 121 because the total patients is 185.
Hmm.
Overdue again.
Okay.
And next one that I want to tell you was the uploading the icon file is almost done. Yesterday, Peter was on 190 something like that. We have 200. The patient's ID number is 200, so it's almost done with Peter and Madeline did. And about the image trial, we try to use the uploaded file in OneDrive, and then we download it again and then upload it to image trial drive. But there were so many errors during the download. So which means we have to upload again directly to the image trial drive. Then the same process should be done again. You want us doing again? It won't take long because we have 3 CD readers right now, and we run almost 4 or 5 computers.
Oh, okay. So yeah, we should do it because yeah.
Okay. And what about the title? Can you tell me which title the best one for this?
Machine
This
learning.
was a previous title. So I think it seems like it's so old-fashioned.
Biomarker status. So are we predicting biomarker status or not?
I don't know yet. After we get the research from Professor Yuri, maybe we can find, or maybe we
Yeah. Yeah, so let's keep it. It's okay. And if we see any correlation with the biomarker response, then we will leave it. If we don't find it, we will take off.
Okay. So then you still want to use this previous title. We keep this one. Right?
Yeah.
Okay. Right. Yeah. I'll move on to the liquid biopsy that you wanted to submit to Lancet Biomedicine. I got almost every author's information, and now 4 authors left. So I tried to reach out again. Do you have any idea how to?
He doesn't respond, Michael O.
No, I sent it 3 times. I sent email 3 times, but these 4 they don't give any.
Okay, I'll have to spend time finding them. If not, if we can't get hold of them, then we can, so. I will send their phone numbers to you.
Okay.
You can text them. That's I
Mhm.
think the next step then. The ones that I know.
Mhm.
Okay, thank you.
And next one is the ctDNA research, and from the partisan, they said that the result is almost coming out. Forget that. And I'm trying to make graph. It was not easy. I'm learning from internet how to make it.
Hmm.
So give me some more time. All I have today.
Anything else?
No, right now.
Oh, did you get in touch with Haluk? Haluk or no?
Look.
H-
No.
No? Okay. Okay.
Michael, Saya, Nicole, and Haluk.
So yeah, I sent three. What's Michael's name?
Michael O.
Okay. What's the other name? Nicole?
Nicole Lambert.
Lambert. Okay. That one I don't know her. So
Uh-huh.
if you can find her contact, you can ask Haluk if he responds to you. And if we don't know, we can't include her. We can't find her.
She seems like working on foundation medicine. So then I can ask the
Yeah,
other.
it's Foundation Medicine colleagues. Yeah.
Yes. So I can ask them.
Okay. Anything else?
No, that's all I have today. Thank you.
Okay. Okay. Uni, do you have any updates?
The the submission, there was some minor, uh, it's not a revision, but like initial quality check. They wanted to include method part and data availability. That's added and submitted. I am not sure what I can do throughout this stay, but for now, what I'm planning on is to submit the hepatitis case report and also helping with Eugene's meta-analysis regarding the cancer incidence and the transfusion.
Yeah, I think that's a lot of work. You could work on that. You could also, if you think that's not enough, you could work on the variant classification project. Dr. Iser Kim and Sally Chung is working on that. So you could divide and conquer with, you can meet with Sally Chung. She has all the raw data. So you can work with her. I think she lives very close to our lab. So you could work, because that project has not been started yet. So you could kind of, yeah, help with her, work with her to finish. And she has some ChatGPT projects as well. So you could work out with her on that as well. And because you're here, you could feel free to come to lab with Sally, and then I can mentor you guys on the project. How long are you staying?
Until 28th.
Okay. Okay, so yeah, definitely happy to have you, and yeah, you could be involved as much as you can. But
Thank you.
really, my focus, as you've seen, is, I think we really have to focus on publishing. I've focused on letting you guys present, write abstracts, and the completion rate is terrible. Like, they get busy and they forget about their projects. So I feel guilty not really pushing them to get it out. It's a lot of it is on my part too. So I'm doing my best to push for excellence, to push for timely publication, and that's doing our patients service. Okay. Maddie, welcome. Do you have any updates on what you've been doing?
No, Peter and I have just been uploading all of the CT files for the radiomics. So I'm on, let's see, 140 right now. So hopefully we can maybe finish it up by today, end of the day.
Yes. And doing the segmentation, I think you guys will learn a lot. What is tumor? What is not tumor? And how is this patient being treated, and why was this immunotherapy used? Don't think of this as labor, but this is all necessary step, and it's someone else's tumor, and what did tumor, how did it change? And some tumors are very hard to delineate, and and think about AI. How will AI be able to analyze all the characteristics of these tumor imaging and try to make any prediction? And it's the one is, does how the tumor look affect how they will respond to our own immune system attacking? It's T cells. We're talking about different immunotherapies, but at the end, it's the T cells that has to be at work. Okay. That's number one. Number two, let's say H&E slide. If you look at the H&E slide, you'll be able to know, 95% there's going to be EGFR mutation. And well, let's say 70%, there's going to be a lot of PD-L1 expression. Just looking at the slide. And can we get to similar level with radiomics? Just looking at the tumor itself. Can we look into tumor biology? Without the help of AI, the answer is no. We cannot know. Like the AI, if you look at the cardiac rhythm variability, you can predict how long the patient is going to live.
Right. Yeah.
If you look at the retina image of a person and look at their blood vessel, how tortuous, or like, is there frail index or something that shows for morbidity, or like diabetic retina, things like that. With all that information, can you guess that person's age? 90% accurately, yes. No, image has a lot of data in it that human eyes cannot discern. So that's the whole idea. So how do you use machine learning in medical science? And we're trying to do that, answering pressing need high unmet need questions.
Right. Yeah.
That,
Yeah, no,
that-
it's very interesting. We've had a lot of like AI lectures
Mm.
in school recently too, because it's becoming such a huge thing. And they've been talking about like using it to read like CT scans and all that kind of stuff. So it's kind of cool that like this is the project, and it,
Mm.
I don't know, it correlates well.
Yes. Well, our first abstract said it didn't correlate. But we're hoping with more sample and using different algorithms,
Mhm.
find something that may work, may not work. So, but it's still, I think it's still meaningful to have well annotated data. And if you have data, that's the power. You can talk to many different labs and apply their algorithm and see what's different. So yeah, and it's just not just but it's the integration of the pathomics, radiomics, genomics, phenomics, patient's BMI. Did you know that BMI is important?
Yeah, yeah. We talked a lot about that and like waist circumference too, all that.
Yeah. Higher BMI predicts better response to immunotherapy. Okay. Uh, there's, I wonder if there's like the fat or the estrogen conversion. There's some, and then we looked at whether patients estrogen SNPs, receptor SNPs affects
Mhm.
the immune response or the biology. The answer seems to be yes. Actually, Michael O wrote that paper. Jian, you can look it up. Michael O and myself wrote that estrogen paper. So there's a lot of one of my friend, Jennifer McQuad. So she was a first year fellow when I was third year fellow at the MD Anderson Cancer Center. And she sat next to me in my fellow room, Jennifer. And she said, "Oh, hey, Young, I'm gonna do palliative care. I'm so interested in you know, uh being an advocate for patient and symptom control." And then in the third year, it's like, I'm so into bioinformatics. This is what I want to do. And her main theme, she got a faculty grant, was BMI and immunotherapy response.
Really? Huh.
Loved analyzing the data, and she found all this interesting relationship between the patient factors like sex, BMI, all that with the immunotherapy results in clinical trials. She built her whole career around that topic.
Wow.
So yeah, you can read her paper like BMI. Her name will pop up. But definitely in the radiomics paper, I think it's good to add BMI and then just come to think of it. And NLR is the same way. NLR should be included as well because now that's an established risk factor.
Yeah.
NLR. I think these are great projects for fellows because they're already there in any medical chart. But the next step is biology. Why? What drives that?
Right.
Male, female biology is now very hot. Why female incidence of Lyme disease and male, why are they different?
Right.
There's some like EGFR mutation. Why are they more frequent in female, not in male? What is it? Japanese has very high incidence of EGFR mutation.
Mhm.
That's how we could develop a lot of EGFR drugs
Oh,
because most trials were done there in Japan, then China. But these difference Where is that coming from? Studying the biology is the next step. But you know, we could be at the discovery phase. It doesn't matter. Keep pursuing the question. But for those of you who just joined our lab is determined to answer questions. Who's going to do well on certain therapy? Who's not going to do well on certain therapy? Who's going to experience more side effect or faster cancer progression? Like, who are these patients? And want to learn everything about these personalized oncology. Can radiomics help? Can phenomics help? Can pathomics help? Can genomics help? Can immunology help? Is organ rejection same thing as tumor rejection? Can we see what's going on there? Can we, it's personalized therapy. If it's mucinous stage 4A tumor, not 4B, which has distant mets, can we do a personalized approach of providing them with transplant for lung cancer? So it's personalized medicine, and it's biomarker based. Haesung's project is looking at biologically what is so unique about that tumor that can be candidate for transplant. And then markers. Treating very heterogeneous tumor versus very clonal tumor is very different. Can we show the difference, and can we come up with a good index, just like TMB? Or immune inflamed score, can we use that to tailor therapy to lung cancer and other non-lung cancer patients? So it's all about finding the right patient at right time and providing a personalized therapy. So for that end, we work, you know, to help our patients. So whatever skill set you guys learn here will be valuable. So look at the big picture. A lot of times you'll be, oh my God, this is the Excel file. I have to fill it up. If that's all you can see, you know, it's gonna be hard, but read, you know, what's the basis of, you know, this theory? What is it? You know, what does radiomics even mean? Like, we had a student come, Dr. Yang now, like, Dr. Che, what is radiomics? I don't understand what it is. So keep reading, keep discussing amongst you. And then you know, I'm happy to be involved in that discussion, because this has to be a motivating process for all of you, not exhausting one. Okay. All right. Liam.
So I have several, but I think it'll be better for me to go over the details in person. But I would like to give you just some updates as broad strokes.
Yeah.
So I had a meeting with Hugh Anderson last week, and he was able to get the agreements out. Apparently, he needs the PI approval signature, so he has sent you 2 emails. Yeah,
Okay.
so I'm not sure about the process behind that, but we need you to sign off on the agreements so those can be sent out. Apparently there was a delay because they were switching over from the InfoEd system to the CareEd system. So their systems were down for like 2-3 weeks, and then he was on a vacation for another week. So yeah, he says he was able to get it out yesterday. He sent me an email, so asking for you to sign off. So I think I can look for those later together and then hopefully sign off so we can send the agreements out. And then I had a meeting with Picture Health, I think, about our NDA research agreements.
Yeah.
We went over the first draft and we made some edits. They sent me the second draft yesterday, so I can go over that with you in person later. I think the major so everything should be good. The only I feel like the rate limiting step there would be to get the path slides. So I was wondering if there was a way for you to maybe, I don't know, call Dr. Alexiev and see if like our lab members can go, or if he was willing to like allocate one of his lab members or fellows.
And this is with Alex, who,
Yeah, I mean, it doesn't have to be with Alex, but we've been working with Dr. Alexiev all this while, so I was just kind of assuming you would request our path slides from him again, but it doesn't have to be with him.
and this is what project you said?
This is for the Picture Health AI. So the agreement is going to be such that they're going to be providing like research grants, and then they are in return expecting to get access to this data file that we're collecting. So I think the radiomics data that we're collecting right now will be the data set that we use with them. And then the ultimate idea was we're going to do both radiomics and pathomics research with them, and kind of use our data set to validate their algorithms, and then kind of collaborate together and look at their data set together and that kind of stuff.
Okay.
Yeah, so I can show you the agreement later and then make any adjustments that we may have. I'm also I'm setting up a meeting with the clinical operations manager. So Lauren Nielsen was the one who did the biomarker study cohort A with us a couple of years back. And unfortunately, she's moved jobs, so she no longer works with us. So I've asked to be put in touch with her replacement, and his name is Rael. I sent him an email. So we're hoping to set up a meeting sometime this week or next week so we can touch base and get the logistics in line so we can start the study. And I also had a meeting with Jennifer from Tempus last week, and we just kind of asked about any updates regarding both the TAP and the Discover projects. And she said she was going to follow up with them and get back to us. And part of that was how Rachel was able to get back to us with those updates. Yeah, so I'm not sure which will be faster. They said they'll be able to, for the TAP project, they said they'll be able to get us the results hopefully by end of June. And that's after having them like bumped us up on the queue. I think we did our job in kind of asking them enough times that they bumped us up. So happy about that. But yeah, I just feel like that just might end up being the faster route. Because if we want to go through the legal process of getting, our postdocs like on an NDA agreement and contracted and everything, that's going to take time as well. So yeah, I mean, that's the situation with the Tempus projects. And then I was able to upload all of the DART posters for your presenter portal for ASCO. I did want to go over them with you because you had 4 like sessions, and I believe 2 of them are like poster discussions. So I wonder if you're like discussants on 2 of them and have to prepare anything separately. Because for now, I just uploaded the posters twice each. So this is the desmoid and the vulvar.
Okay. So are they both
So I think
poster
that
discussion sessions, desmoid and vulvar?
that's what I'm gathering from what I saw on your portal, but I think that's something we should go
Okay,
over
yeah,
together.
let's do that. So poster discussion
Mhm.
means the first author be present to answer questions, but the discussant discusses the result.
Oh, okay.
Yeah,
So
yeah.
maybe
I don't have to say anything, but I have to provide slide and just, be up there at the podium to answer questions.
sure. Okay, yeah. And so that's another thing I'd like to go over with you later. And then a lot of like ASCO scheduling stuff.
Yeah, let's talk about that because I'm here. all day here.
Yeah. I think that's kind of the overall update, and then all the details I'll like to go over with you in person later in the afternoon, probably.
Okay, very good. We have some time. Dr. Chion, do you have follow-up on the PARP inhibitor?
No,
Or
sorry, I'm still
you're still
looking
working
for,
on it?
but yes, but it was I couldn't find so far.
Okay, yeah, whatever you find,
Mhm.
let me know if you are ready to present. And Haesung, do you have anything you prepared? I know you've worked on many things.
I have the neoantigen intertumoral heterogeneity review.
Okay.
And then I have the PARP inhibitor ICI combination
Yeah. Let's talk
presentation, and
about
then
that.
the tissue TMB versus blood TMB concordance stuff.
Mhm.
Which
Oh,
one
and
would you
Dr.
like
Chi,
me to present?
oh,
Yeah. No, go ahead, Liam.
oh, yeah, no, I just wanted to ask, so I think you have a garden meeting at 11. Is that something you're going to?
Mhm.
Okay. And do you need any of us to join?
No, this is Zoom meeting. Yeah, you don't need to. Yeah. Garden? Yeah, for garden, maybe, let's see. Okay, for the garden meeting, Maria, Uni, Maddie, can come into my room and listen. I'm
Um,
presenting through Zoom, so.
I have a SRSP lecture I have to go to at 11 today.
Oh, then next time.
Yeah.
Okay. Okay. So you can proceed.
Which one would you like me to start with?
Oh, anything. It's okay.
Okay. I think. Okay, yeah, I'll start with the PARP inhibitor and ICI combination therapies, what's out there. So I reviewed 3 different review articles on for this topic. And these are the list of EMA and FDA approved PARP inhibitors. And for now, at least, they're only indicated for breast cancers, or ovarian, fallopian tube, peritoneal carcinomas. So that includes olaparib, rucap, yeah,
First, the peritoneal carcinoma.
peritoneal carcinoma. These are actually considered same, type of cells, so they're often like categorized into a single carcinoma.
Oh, yeah. So that's basically same as ovarian.
Yeah, basically.
Okay.
So I'm just showing you the list of currently approved PARP inhibitors, and that's olaparib, rucaparib, niraparib, talazoparib. In preclinical studies, PARP inhibitors.
Go back to that slide. I just want to teach you guys. Is there a way to make this a little bit bigger?
Yeah, it's nice.
Next slideshow. Yeah,
Is
that's
that
better.
nice? Okay.
Yeah, that's better. So I want you to know that these drugs are approved. Look, germline, BRCA, for breast and ovarian. But then you have the concept of HRD, homologous repair deficiency, positive. And you have BRCA mutated pancreatic cancer. And for ovarian, there's monotherapy, but it's sometimes in combination with chemo or bevacizumab. Um, And for breast cancer, BRCA 2022, you have early breast cancer treated with adjuvant or neoadjuvant chemotherapy. And they're given olaparib in this setting. So this is like the new development of PARP. And then lucaparib is BRCA, or for ovarian, you have independent of BRCA. So everybody gets olaparib for recurring ovarian. Niraparib is everybody and sometimes HRD positive. And same thing. But then talazoparib is not ovarian, but just breast cancer with only germline positive. So there's, there's different nuances here. Next.
So in preclinical studies, the PARP inhibitor has demonstrated synergy with ICIs in a variety of tumor models, regardless of the BRCA 1 or 2 defect. It was demonstrated that PARP inhibitor-based therapy synergizes with anti-PD-1 against both microsatellite stable and unstable colon cancer models, with a potential sensitizing effect of anti-PD-1 therapy against MSS tumors. Another study demonstrated that the combined use of PARP inhibitor and ICIs against colon and ovarian experimental tumors, regardless of the BRCA1/2 mutation status of the cell lines, assessed both in vitro and in vivo. I've also listed, several other studies showing the synergy effect. So together, these data reinforce that the combination may be beneficial in tumors, regardless of the DNA repair status, which has important clinical implications. So here's a list of completed studies on PARP inhibitor and ICI combination in humans. The Mediola study, for example, they studied the efficacy of durvalumab and olaparib in both breast and ovarian cancers with germline BRCA1/2 mutations. The regimen was well tolerated and resulted in promising PFS and deep and duration of response. The Tapasio study evaluated pembrolizumab plus niraparib in triple-negative breast cancer and ovarian cancer, irrespective of germline BRCA mutations, unlike Mediola. And in breast cancer, nearly half of the patients achieved durable clinical benefit with stronger activity in BRCA mutated cancers. But on the other hand, in ovarian cancer, patients responded to dual therapy irrespective of BRCA and homologous recombination deficiency status. So there are different results for breast and ovarian cancers. And then
So let's look at it. Oh yeah, are you gonna do pemiparib? Okay, go ahead.
Okay, but it's just the last thing I wanted to mention. The pemiparib and the tislelizumab combination was generally well tolerated and associated with anti-tumor response of 20%.
No, then it's any solid tumors, right?
Yes, this is any solid tumors. Sorry, that's why I wanted to mention.
Yeah. So
And compared to
negative,
this one, it was a lot higher.
So triple negative breast cancer, or was about 20% response rate. And BRCA positive was about 56. And then all solid tumors about 8% here. The next one is BRCA mutated ovarian. Just 3 patients, so I don't know what that means. 35 patients, ovarian and all comers, 14%. Platinum resistant ovarian is 20%. So if I have to choose whether I want to develop this or not, it looks like response rate is a lot higher in, BRCA mutated, and you don't really know whether PD-1 is adding something or not. But based on this, you're kind of a little bit skeptical where you want to go. Because the question is PARP doing this? PD-1 adding something? It's hard to know. And
Yeah, I think these are all
20%,
single arms.
yeah, there's no comparator. Next.
I just wanted to show the ongoing studies. So these are combination with olaparib, with tremelimumab or pembrolizumab, and then atezolizumab, durvalumab, and both tremelimumab and durvalumab. Also with niraparib plus the trilimab, dostarlimab, pembrolizumab, atezolizumab, sintilimab. These are in rare cancers. Talazoparib plus nivolumab, atezolizumab, avelumab, rucaparib with nivolumab, atezolizumab. And then for 1 second. And so the mechanisms that have inspired numerous PARP inhibitor-based combination therapies, including immunotherapy, also capitalize on the potential synergistic effects of different inhibitors of the DNA damage response pathway, such as ATR, ATM, and checkpoint kinase 1 inhibitors. So preclinical data have demonstrated the direct cytotoxic effects and enhancement of anti-tumor immunity by ATM, ATR, and CHEK1 and 2 inhibitors. There are many active clinical trials using other DDR inhibitors, either as monotherapy or combination with PARP inhibitors. Then here, let's see. These are other inhibitors, but I also found some DDR inhibitors and ICI combinations that are undergoing trials currently. We don't know the data yet, but these are combinations with like pembrolizumab. I guess this is with the leopard and avelumab. But yeah. Yeah, just a lot of ongoing studies. No good results so far. These also include like head and neck cancer, there's small cell lung cancer, nasopharyngeal cancer, gastric, non-small cell lung cancer.
Okay. There's meso, cervix, endometrial, head and neck, endocrine. Yeah. Is this all for this topic?
Yeah, for this topic, yeah.
Thank you. So people are not giving up on this. PD-1 plus DDR inhibitors, whether it's PARP, ATR, ATM, so this story, two-hit Kutzen, his theory of two-hit, and then that DDR inhibition leads to immune inflammation. People are thinking there's gonna be a synergy when given together. and Dr. Chiang is going to look into that question. Why is giving PARP detrimental in some patients? Um, there's not going to be a lot to read. So it's more of scientific thinking. Why? Why did these group do poorly? So it's the same question we're delving into. Why do patients die sooner if you give immunotherapy? Why do patients die sooner if you give PARP inhibitor? Because you want to say, at least I did no harm. And a lot of companies, I think 3 of them withdraw their PARP inhibitor, the FDA approved indication. So why is that? Maybe Haesung, you can think about that, discuss that with Chia, okay? Because you read enough here. It's much more fun if you do discussion amongst yourselves. But the jury's still out there. The companies are not giving up the combo. I told you to look into it because I got funding from BMS to look into olaparib plus nivolumab. That was my first investigator-initiated trial. I got the funding and I did run the study. Still trying to think. So Liam, do you know who's writing up that trial? Is it Dean or Richard? Remember there's a Nivo plus metformin, that there's a Nivo plus olaparib.
Oh, yeah. So they should be. Aren't those the ones that Dean was working on?
Yeah.
Yeah. So Dean was working on them, and Richard was helping. I asked Dean for an update. I haven't heard back from him yet. I'll ask him again. But I
Wait, Liam,
saw
wasn't it
Richard last.
veliparib and oh, sorry.
Oh yeah, that olaparib. Veliparib, good point. Veliparib.
It was veliparib, not olaparib.
Yeah, veliparib plus Nivo was the trial.
Yeah.
And our response rate was 0. And we looked at BRCA likeness or HRD positive, okay? In my trial that I wrote probably like 6 years ago. So let's talk to Dean. Why isn't there any progress?
Mhm.
And if you want to learn how to write clinical trial result, you can work on this project as well if you want.
I believe these are all almost all written up. They just need to be reviewed and published or submitted.
So let's see if something has to be done.
Sure.
I don't know what's going on with Dean, but yeah. So Liam, please follow up and let me know. Okay.
Will do.
But this is how things get lost. Like they keep giving update and they disappear. So it's hard to keep track of all the okay, next.
Oh. Let's see. Yeah, so the heterogeneity, neoantigen heterogeneity, and then the blood TMB, tissue TMB concordance. This is the one that stats wrote. And you wanted me to review this before starting the top project. Which one? Right.
What are you waiting for?
Oh, sorry. I just didn't know what's. I thought you were busy doing something. I didn't know which one you wanted me to present.
Oh, yeah, either one's fine. We could, I think I have time till 11. so-
Okay. Okay. So this is about assessing tumor heterogeneity, integrating tissue, and circulating tumor ctDNA analysis in the era of immuno-oncology. And then the main point is that blood TMB is not the same as tissue TMB. The tissue TMB is defined as the total number of mutations per exome. It's associated with tumor neoantigen load, which is predictive of treatment outcome. And to estimate this burden, single biopsy tissue TMB is routinely used. In several studies, increased response and survival and durable clinical benefit were seen in cancers with high tissue TMB. And to bring out further utility from TMB, clinicians have attempted to use it alongside MSI. MSI is determined by measuring the additional or removal of new nucleotides from microsatellite cells. In the context of immunotherapy, MSI has shown to predict treatment outcome, especially with mismatch repair mutations. It's especially when mismatch repair mutations are considered. Even though MSI and tissue TMB have predictive value, they're not the same. Let's see. And I listed some examples of they're not the same. It's kind of long, but maybe I'll skip for the time sake. The sequencing methodology used to obtain the raw data is an important consideration. Whole exome sequencing selects for long stretches of DNA covering mostly exons, with some introns and intergenic regions. The use of gene panels is an alternative approach that targets a list of genes ranging in number from below hundreds all the way to thousands. The third and final method is whole genome sequencing. And in this case, all available DNA fragments in the sample are sequenced, capturing interexonic regions. And despite this advantage, the high cost and high material requirements of WGS makes it unlikely to be utilized clinically. But most importantly, less costly alternatives like gene panels and WES can be used to effectively measure clinically relevant biomarkers such as TMB and neoantigen load. The larger the panel, the higher the correlation. So although single biopsies are the standard for most clinicians, they come up with a significant number of limitations. The biopsies are invasive and can be only performed on accessible tumors of the appropriate size. Additionally, several studies have shown that a single biopsy does not capture the entire landscape.
Okay.
Yeah, so it just does not capture the mutational state of the tumor. So liquid biopsy can add another data point to complement situations in which the opportunity for tissue biopsy is limited. Blood draws are routine and non-invasive, making them ideal procedures for disease monitoring and treatment assignment. So the presence and abundance of ctDNA has been associated with clinical outcome. But the concordance between tissue TMB and blood TMB is of primary research importance. In studying the concordance, it's important to acknowledge the technical differences between the tissue TMB and blood TMB assays. Among the 4 commonly used assays, the Foundation 1 CDX, Tempus XT for tissue TMB, as well as Guardant 360 and Guardant Omni for blood TMB, there's variability between both gene panel size and allele fraction percentage limit of detection. There's also individual assay differences in the DNA extraction methods, sequencing library preparation, sequencing parameters, and raw data processing. And these can all be sources of bias that can affect the concordance. They're also, they use different cutoffs for tissue and blood. So one study proposed that blood TMB carries two types of bias. The first is called the big tumor burden effect, where a larger tumor will shed more cells, resulting in higher amounts of ctDNA. The second is tumor heterogeneity, so low frequency mutations represent minor subclones. And while it's clear that patients with a large tumor burden generally have a worse prognosis, patients who exhibit high levels of tumor heterogeneity via their subclonal LAS mutations are currently not stratified in clinical practice. So a preclinical study, a preclinical study discussed. Sorry, it's been a while, but I think I'm going to take this part out. But anyways, yeah, so we need more accurate predictive tools to distinguish between treatment sensitive homogeneous cancers and heterogeneous cancers capable of harboring treatment-resistant subclones. So assessing tumor heterogeneity has most commonly been accomplished by quantifying the frequency of different alleles across key genes, their copy numbers, and sequencing. The diverse algorithms that have been developed and validated have their respective advantages and disadvantages. And a selection of these methodologies are summarized in this table, and we'll discuss each one briefly in the following slides. The PyClone, a Bayesian statistical model, is designed to establish a cluster architecture from ctDNA data. It uses allelic frequencies, read depth, and copy number variation to estimate the size of a cell population that carries a given mutation. And if several mutations are present at the same cell population size, then they're considered clustered. The cluster number and size can then be used as an estimation of the number of clones within the sample. In other words, heterogeneity. So this approach relies on two assumptions about clonal populations. One, that they're perfect, meaning no single mutation occurs more than once, and that for each mutation, there's only one somatic genotype. And two, that they're persistent, meaning that mutations don't revert to their somatic genotype. And so with these limitations in mind, PyClone has been used as a general way of assessing heterogeneity in several studies. A variation of PyClone, this one is called Cyclone, and it was recently developed to provide higher confidence heterogeneity assessment. It takes a narrow range of loci as an input. These genes come from copy number neutral and loss of heterozygosity-free proportions of the genome. The intention is to provide a higher confidence measure of variable allele frequency, which is abbreviated as VAF. And VAFs are subsequently clustered using a variational Bayesian mixture model. And then there's the allele frequency heterogeneity, which is a simpler approach which yields a score rather than a set of clusters. It uses the abundance of low frequency alleles as an indicator of high or low heterogeneity. And the presence of allele frequency heterogeneity was significantly correlated with unfavorable overall survival in patients with non-small cell lung cancer. Another approach is called mutant allele tumor heterogeneity, MATH. The basic unit of this calculation is the mutant allele fraction, which represents the percentage of sequencing reads that contain a tumor-specific mutant at a given locus. And the distribution of all mutant allele fraction values and their respective abundance can represent the heterogeneity of a tumor sample. So higher MATH scores were independently associated with decreased overall survival in head and neck squamous cell carcinoma, colon cancer, and breast cancer. The Shannon's diversity index takes the variant allele frequencies of a given set of mutated loci and sums the natural log of the probability distribution for each across all the loci, yielding a score or index. It's been applied to colorectal cancer cohort. It was observed that the stage 1 to 3 patients with high Shannon diversity index exhibited a shorter PFS. And now finally, our team would now like to propose a hypothetical index called the tumor heterogeneity index that we believe may be able to quantify heterogeneity by taking into account both blood and tissue data and differentiating between clonal and subclonal mutations. And we believe that it's the detection and quantification of subclonal mutations that determines how heterogeneous a tumor is. And this is basically what my TAP project will be on. So this is something that can be coupled with other metrics, such as TMB to minimize bias.
Thank you for summarizing. So this is what we developed with STAS. And Chae-Yoon Choi initiated the project, and this is sort of the paper we wrote together. I was thinking like a pioneer. We're still the pioneer in this field, trying to work with companies who does both blood and tissue. To me, I cannot understand why they are not coming up with a composite index. Both are very different biology. We're not saying one is gold standard. We're saying we need to use both data to say what is the clonality, what are the subclones, what are the clonal mutations. So it's still in the works. So so Liam, with the Guardant raw data, where are we? Like where where are we in terms of getting that data?
Guardant raw data?
Yeah. Remember the FIRAS has the access, and they said that we don't have the access. The Guardant says Northwestern already has it.
Right. Let me check in on that. Yeah, so we had a meeting with like the gate manager or something, like kind of like a data manager for that portal.
Okay.
And then they said they were going to, there was an issue that they needed to sort out, and then they said they would get back to us, but they didn't. I'll follow up with them.
Yeah, this is important. If we get access to the raw data, then we should be able to do all different analysis, comparing that data with the Tempus data. And when we get the Guardant data, Haesung, you'll be working on, based on this concept, what can we do? So first, learn about the data, what's available, what's not available from the Guardant. And then Tempus, who has both TMB, blood and tissue TMB data, and go from there. But yeah, Haesung, why don't you work with Liam to get the Guardant data? I mean, Stas is busy, so, but yeah, you two can work on having the access to downloading the raw data, and what is the data structure, and how is it, there's two different versions of Garden. One, I think it's been like almost more than a year now. There's a version where you have blood TMB, there's a version you don't. And I think it'll be really good if we can have access to the blood TMB, the raw file. Because here's the thing, in order to get blood TMB, you need more than 300 gene profiling. And that gene, the cover length is it's more than usually 1.1 megabase pair. And that's usually what's required to get relatively accurate TMB. If you have panel that is about 70 genes, you cannot get a reliable TMB. The problem with Garden is that they report, like, let's say 70 gene mutations. They don't report 300 gene mutations. They only use it to calculate TMB and they never report it. But they have information on that. They just don't release to the public or to doctors. So I think our next question is, is there a way for us to get that raw data? That way we can accurately assess clonality using both blood and tissue. So keep that in mind. Let's keep asking that question to Guardant. But that's our second plan. First plan is let's actually get the raw data first and see what that contains. Okay, very good. What do you have next?
We can hear you. Yeah, Hassan.
I have a neoantigen heterogeneity one. This is by McGray-Shanahan. Would you like me to talk about this one?
Oh, this is the initial paper. Yeah.
Okay. Yeah, so it's titled
Just briefly,
Clonal
5
Neoantigens.
minutes.
Oh, wow.
Mhm.
I can present later then. I think I've prepared a lot for this one.
Oh, really?
Could we
Okay,
maybe do this
then let's do
later?
it
Yeah.
later.
Okay.
Yeah, let's do that. Because, that's a really important paper too. Yeah. Okay, since we're doing it next time. So the concept of that clonality affecting immunotherapy response was first introduced with that science paper, 2016. So it's been 7 years, okay? So since then, my next question to you, is there any follow-up paper that showed the same or even better concept in that field? Asking the same question. Clonality of the tumor affecting the response from immunotherapy. Maybe there is, maybe there is none. But if you can look into that, and then maybe one more paper or 5 more paper, if you can kind of read into that topic, because that's your project right there, heterogeneity and immunotherapy response. So if you can do that research and present in our next journal club, that would be good. Okay. All right, so we'll wrap up here, but I will say, keep reading, build your hypothesis, convince yourself. If you cannot convince yourself, you're just doing work for somebody else. You have to understand, why am I doing this? Why is it meaningful? And what are you contributing to? I can tell you to do things and learn from the research process, but it's up to you to read and understand the whole field. That's what you will truly get you into doing things. Okay. Okay, we'll wrap up here and we'll see you guys later. Thank you.
Thank you.